Dear student, in this lecture we will discuss alpha decay. Alpha decay is a process of production of alpha particle when a when an unstable parent nuclei split into daughter nuclei and its release to protons and two neutrons. So these two protons and two neutron combines and form alpha particles. So now let me write the definition of alpha decay. Alpha decay is a process in which an radioactive unstable radioactive atom or nuclei splits into stable daughter atom or nuclei and release two protons and two neutrons, form alpha particles. Dear student, alpha particles are represented by a symbol alpha. Alpha particles are also known as helium nuclei. The reason that alpha particles are said helium nuclei, since you know that the helium atom has a nucleus and it has two proton and two neutron. Similarly, alpha particles uh, are also made up of two protons and two neutrons. So that is the reasons due to which the alpha particles are also called helium nuclei. Now, students, let us give example of alpha decay. Consider uranium-238. Uranium-238. The term in a subscript which is 92 represent atomic number. Atomic number is basically it is a number of protons or electrons in an atom. Whereas the term in superscript 238 basically it's represent mass number, and mass number is represented by a term Z, which is basically it is a number of protons plus number of neutrons in atoms. So dear students, since you know that alpha particles are basically formed when two proton and two neutron combine, okay? So this means that in uranium atom, the number of uranium atom, the number of proton will be decreased by 2. So if we write that number of proton in uranium atom are, let me clean this first. Since dear student, as you know that the atomic number is number represent number of proton or electron, so number of proton in uranium 233 are 92. Similarly, number of electron which are basically equal to number of protons, so number of electron in uranium 238 is also 92. Now, as you know that atomic weight or atomic mass is number of protons plus neutrons. So the number of, we know the number of protons, then we know the number of protons in uranium 238, which is 92. So then the number of neutron in uranium will be, we will basically minus 92 from 238. So the number of neutron in uranium 238 will be 146. So we can write here that number of neutron in uranium atom are, uranium 238 is 146. So now this uranium atom is converted into alpha particle, which we can write with helium nuclei, or we can also write it with symbol alpha. So now the two neutrons, when the uranium is converted, uranium basically is uranium give alpha particle, so the number of neutron in uranium atom, number of proton will be decreased in uranium atom will be decreased by 2, and number of proton will become 90. Similarly, number of neutrons, as uranium atom give neutrons, so it will in form of in forming alpha particle, uranium atom also lose 2 neutron. So the number of neutron will be 144. So the new element, as you know that in periodic table, the new element, every element have its own atomic number, and elements are basically are recognized by atomic number. So the new element, the atomic number of new element after uranium forming an alpha, after uranium releasing alpha particle, the atomic number of new element will be 90, and as well as the atomic mass, as you know that, or atomic weight, as you know that it is number of protons. So we have number of proton 144, so number it is basically number of neutron plus number of protons. So the number of neutrons are of 144 and number of protons are 90. So the atomic mass of new element will be 234. So we can write the new element as the atomic mass of new element is 234, whereas the atomic number of new element is 230 is 90. So if we check the element in periodic table, that which element has atomic number 90. So we can basically get that we basically the decay of a uranium into an alpha particle form a new element, and that is thorium, having atomic number 90 and atomic weight 234. Now dear student, please keep in mind that the reaction, nuclear reaction or a chemical reaction which is take place during the formation of alpha particle is a balanced reaction. It is always balanced reaction. So the number of proton or neutron in this reaction will be balanced. If we consider the left side of this equation, we have number of protons. If we consider the left side of this equation, we have number of proton 92. So if we consider the right side, an alpha particle has 2 protons, and whereas the thorium has 90 proton. So when 2 plus 90, it will become 92. So number of proton on the left side are equal to the number of proton on the right side. Similarly, number of neutrons on the left side will also be equal to the number of neutron on the right side. Number of neutron on the right side is 146. Now number of neutron in alpha particle are 2, and whereas the number of neutron in thorium are 144. So number of neutron in on the right side of the chemical equation is 146, and number of neutron on the left side of the chemical reaction is 146. So both the reaction on the right side is balanced, and it is equal to the reaction on the left side. Now consider some other example of alpha particle decay. Consider the alpha particle. Now student, consider the radioactive decay for another isotope of uranium, which is uranium 233. Since you know that the 92, the term in a subscript 92 basically represent atomic number, and whereas the term in a superscript 233 is basically represent an atomic weight of uranium 233. So the number of proton in uranium 233 will be basically will be 92, since you know that the atomic number is a number of proton or electron in an atom, whereas number of neutron in uranium 233 will be, as you know that atomic weight is a number of proton plus number of neutrons. So now the atomic weight is 233, and we know that number of proton in uranium 233 is 92. So we will get the number of neutron, we will get 141. So number of neutron in uranium 233 will be 141. So now, student, when this uranium 233 is converted into a daughter nuclei, it releases the alpha particle. As you know that alpha particle are 2 proton and 2 neutron. So this means that a new element which is formed due to a radioactive decay, alpha decay of uranium 233 will be will consist of a proton, and these proton will be 2 less proton than the uranium 233. So number of proton of new element will be 90. Similarly, number of neutron of new element will be also 2 less. So number of neutron of new element will be 139. So now, as you know that number of proton and neutron make an atomic weight. So atomic weight of new element will be 229. So we will add basically number of proton, which is 90, and we will add number of neutron, which is 139. So total number of proton and neutron make atomic weight of new element will be 229. So now the atomic number of new element which is formed due to the alpha decay is 90, and whereas the atomic weight of new element is 229. So we need to check in a periodic table that which element has atomic number 90. So we can read that it is basically a thorium atom, or it is an isotope of thorium which has atomic number 90. So dear student, uranium-233 when releases alpha particle, when it releases two proton or two neutron from its nucleus, it forms a thorium isotope, thorium-229 isotope. Now, interesting question here is that number of proton on the left side of the number of proton, neutron, and electron on the left side of chemical equation are always balanced with the number of proton and neutron and electron on the right side of the chemical equation. So we can check it also. Both the sides of the chemical equation will always be balanced. So number of protons basically on the left side of the chemical equation is 92 total number of proton, whereas here if alpha particle has two protons and similarly thorium has 90 protons, so total number of proton become 92. So the proton on the left become equal to the proton on the right. Similarly, number of neutron on the left of the chemical equation is 141. Now in here the number of neutron in alpha particle is 2, whereas the number of neutron in thorium is 139. So when we combine 139 with the two neutron of alpha particle, it's become 141. So this means that the equation on the left side is balanced with the equation on the right side. Now distant, let us consider some other examples of alpha particle decay. Considered the problem for the alpha particle decay, we have on the right side we have a new element. Suppose it is proactinium Pa with atomic number 91 and atomic number 238, and along with the proactinium it consists of alpha particle arhenium nuclei. So now we need to calculate that what element is basically causing the alpha particle decay, or what is the element which is basically splitting into proactinium. So for this, as you know that alpha particles are consist of two protons and two neutrons, whereas atomic mass represent number of protons plus neutrons. So the atomic mass of new element proactinium is 233. However, since you know that alpha particles have two proton and two neutron, so this means that atomic mass is number of proton and number of neutron. So four new proton, two proton and two neutron will be added in proactinium. So the parent atom, the atomic weight of parent atom will be 237. So the atomic weight of parent atom will be 237. So we can write that the atomic weight of parent atom is 237. Now, as you know that the atomic uh, uh, atomic number Z of the proactinium is 91. So they basically proactinium is along with the alpha particle, and atomic number basically tell us about the number of protons. So alpha particle has two protons. So the parent atom will consist of atomic number with two more protons. So the atomic number of parent atom will be 93. So here we will write 93. So now we need to check in periodic table that what is an element having an atomic number uh, 93. Student, if we check the element, then we can find that it is basically an element known as neptunium having an atomic number 93. So in this way basically we can calculate or we can solve the problem where we are unknown, we are not known about the parent nuclei or parent atom, and there is a problem where we have idea or we or it is mentioned that a daughter nuclei or daughter atom is known. So we basically add number of proton and neutron of alpha particles, and on the basis of that we can need just to calculate atomic weight and atomic number, and on the basis of that basically we can find that what is basically parent atom, which is split it into daughter atom or nuclei and alpha particle.